The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. I hope you're able to hear me. Can I get a audio and visual double check just to make sure we're broadcasting correctly? If anybody wants to, thank you very much. So welcome to today's program. The title of this program is Residential Equipment Sizing, Manuals J, S, and D, including the provisions of the Wisconsin Uniform Dwelling Code. And we're just going to be reviewing what Manual J, S, and D are and how they apply to residential construction. Looking at some of the best practices and some of the code requirements that are in the Wisconsin Uniform Dwelling Code when it comes to residential HVAC sizing. So today we're on GoToWebinar. If for some reason you lose audio, you can certainly log in via phone call using the number that was in your access code email, but please stay logged in on your computer so that the attendance will be tracked. We do have handouts available for today. You can download this slide deck as well as an HVAC design review worksheet or checklist that could be used just to make sure that you have everything in place and you meet some of the code requirements in the documentation. The seminar is going to be recorded as well. You'll be sent a link for the recording so you can download and bring that into any media of your choice. If you have questions, please use the question pane. Put that in. That comes to the admin personnel, as well as we can also keep track of those questions if there's something that we have to answer after the fact. Also, we'd like you to put in your DSPS candidate, your identification number, if you could, in the chat or in the questions pane so that we can make sure we have the correct number for you when we go to submit for the CEUs. You'll be receiving a certificate of participation today. So this is for you, worth 1.5 hours of continuing education for Wisconsin DSPS, as well as ICC and AIA. Again, please, if you would put your DSPS customer ID number in the question pane, that'd be greatly appreciated. You may have entered that already at registration, but just to make sure. Also, the certificates should be mailed out within a week to two. Aaron is usually really good based getting these out quickly, but based on the number of classes, there may be a little delay. Sometimes these get pushed to your spam or junk folder, so just be aware of that to look at that point. And we'll also be registering this with DSPS. So this overall program, is part of the Wisconsin Energy Code Technical Advisory Program. The sponsors include Clean Wisconsin, Wisconsin Local Government Climate Coalition, Midwest Energy Efficiency Alliance, New Buildings Institute, and Slipstream. The intent of this program is across the state of Wisconsin to provide code understanding and provide technical assistance and questions, or answer questions by stakeholders across the state of Wisconsin. So we are offering virtual or in-office job site visits. We can talk to small groups, one-on-one consultation. We'll have some contact information shortly, such as this virtual training. We do live webinars, and we will be doing in-person trainings around the state as well, involving building science and various other things incorporated with the code, the residential and commercial building code is incorporated into the state of Wisconsin. And again, if you have any questions on energy code, anything that's related to the energy code, please reach out to us. Additional information on the program can be found at www.wienergycodes.org. And you can also contact Robbie Oakley at roakley@psdconsulting.com. In conjunction with Slipstream, they're doing a code compliance study for residential and commercial new construction to get a baseline of what is across the state of Wisconsin. Again, you can refer to that WisconsinEnergyCodes.org website for additional information pertaining to this study county by county around the state of Wisconsin. This presentation today is being brought to you by PSD. We will provide the training and technical assistance and outreach for energy efficiency codes, and PSD, or Performance System Development. Additional information can be found about us at psdconsulting.com, on LinkedIn, and on YouTube. My name is Bill Dieters, the individual on the left, Senior Technical Specialist with PSD. I'll be doing the presentation today. Robbie Oakley, our in-state Wisconsin technical advisor, will be in the background answering questions and will introduce himself here in a few minutes. Just a brief history on me. I've been involved in residential and commercial construction since 1988, everything from plate architecture, design, and estimating through construction superintendent. I'm also a licensed ICC code official, energy code and construction code. I'm also a HERS rater and QAD, and been dealing, like I said, between single family and multifamily and commercial construction since 1988. Robbie, you want to talk a little bit about yourself?
Yeah, hi, I'm Robbie. I'm here in Wisconsin there with you. I went to the University of Platteville, Wisconsin, and got a degree in sustainability and renewable energy systems. I've been working since 2021 with PSD, coming up on 4 years now, and in my free time, not doing this, I do the Focus on Energy New Homes program. I do the QA for that. And I'm also a ResNet rater and QAD.
Thank you, Robbie. So, if you have any questions, again, you can contact either one of us at these email addresses, and typically we'll be able to get back to you within a 24-hour period for questions if you have technical issues really as it pertains to the energy efficiency code. If there's anything that comes up during this presentation, just be sure you can drop it in the question pane. And if we're not sure of the answer, we will certainly research that and get back to you. We don't pretend to know everything. So if there's something that's out of the ordinary we're not familiar with, we'll definitely research and get an answer back to you within the day or so. Here's our contact information, both phone numbers and email. So we're available for energy code support via phone through the business day, typically from 8 a.m. to 5 p.m., and then via email 24 hours a day. And we'll respond to both phone calls and emails with a follow-up email within the 24-hour period. So the agenda today, we're going to talk about some related code sections with the UDC. We're going to discuss a little bit about ACA, the design process in which ACA administers. What are manual J's and manual S's? What do they do for us? How can they be used? Talk a little bit about some consequences of improper HVAC sizing, whether it's undersizing or oversizing. And then take a look at individual manual J, S, and D, what the reports for manual J are, how we use manual S, which pertains to sizing. Manual J pertains to the heat loss, heat gain calculations for a home based on its specifications in the as-built location and orientation and so forth. Manual S are the guidelines for sizing of heating and cooling equipment. And the manual D is the duct design or duct layout sizing and using the manual J and the manual S. And we'll look at how the reports, or review the reports, and what some of that key information we need to be looking at. And we'll have some time for questions at the end, hopefully. So we should be right around an hour and 15 minutes or so with this. So hopefully we'll have some time at the end to discuss. So hopefully at the end of this presentation, you will be more familiar with these requirements. Hopefully you're already familiar with these. The code requirements for load calculations and the sizing of heating and cooling equipment, and understanding manual J. That ACA manual J can help save initial equipment costs, operating expenses, can promote prolonged equipment life, and improve comfort and conserve energy. As long as it's designed properly and the information is entered properly. So modeling the home, whether it's via just a spreadsheet calculation or using a software package, we can determine a room-by-room BTU loss during the winter seasons or heating seasons and BTU gain during the cooling seasons. That's, again, based on those specific building specifications, the location of the building, as well as the orientation. Manual S, properly sized HVAC system prevents problems such as excess expense. We're spending more on energy than we have to. Decreased comfort, marginalized performance. A improperly sized HVAC system could lead to additional moisture issues, comfort issues where one room is too hot for a portion of the time period and cooled the remainder, or the opposite. So we want to be able to get the HVAC equipment sized based on the heat loss, heat gain calculation, so that we're not putting larger or smaller HVAC systems under our homes and that they function as intended from the manufacturer. So taking the manual J and the manual S, bringing those together, we have the manual D. That's the industry standard for a duct system design to distribute the correct amount of conditioned air to each room and to provide that low resistance path from an HVAC system to each room and back again from the supply ducts as well as a return. Proper air distribution system is crucial to occupant comfort, making sure that we get the amount of air that's required by the manual J delivered to that room over a garage, and then we're getting that air back into the system. That we're not losing air through duct leakage or improper install. We're getting it distributed appropriately. So we don't have a small bathroom that's going to be extremely warm or cold, in bedrooms or the opposite, making sure that the air is sent where it's required by the manual J. So when we look at the UDC, this table 322.31-3 just sets the minimum efficiencies for sealed combustion units for natural gas, propane, and oil. So again, looking at the code, I'm sure everybody's familiar with that. We're going to just relate to a few passages at the beginning of this presentation to the code itself. SPS 322.40, it's indoor temperatures and equipment sizing is what it pertains to. Basically, our indoor design temperature for unheated and non-habitable basement areas should be less than 50 degrees Fahrenheit. And all other areas of the dwelling shall be at 70 degrees Fahrenheit for a heating design. And then our equipment sizing, again, manual S, ideally would be based on a manual J calculation, that room by room design load. But as we can see the passage in the code stating that heating and design loads, including ventilation loads, for the purpose of sizing to be determined in accordance with ResCheck or REMRate software programs, or one of the procedures described in Chapter 29 of ASHRAE Handbook of Fundamentals. There's also a subnote within the code stating that residential heat balance, load factor, Canadian F280, and ACA manual J and S are among the methods recognized as equipment sizing protocols. So it's important when we start to look at using ACA manual J and S, making sure if we go a software route, that software package is recognized by ACA and ASHRAE for use with manual J and manual S size. And you can still do paper calculations, but calculations by hand, not as accurate as what the software will be. Note that the code the UDC does not specifically require the use of a programmable thermostat, just that each system should be provided with an adjustable thermostat for the regulation of temperature. Okay, and of course, mercury-based thermostats are prohibited to be installed. And if we have heat pump, we have a heat pump in the home, the supplementary heat guideline saying that the controls, of course, will prevent that supplemental heat from operating when the heat pump compressor can meet the heating load requirements. We'll move on to duct systems, SPS 322.42. So the Wisconsin UDC specifies framing cavities may not be used as supply ducts, which means that they could be used as returns, or cavities for return air is acceptable, even though that's not the best practice. Proper sealing of these cavities along the entire length to minimize leakage both in and out of that framing cavity is often difficult to do. We can still use return or building framing cavities as supplies. If we have ducts outside of conditioned envelope, they need to be insulated to R8. And if there are cooling ducts in the attic, they need to have the exterior insulation that has a vapor retarder installed. So when we have ductwork outside of conditioned space, it's an R8, minimum R8 insulation. And we can still use returns as framing cavities for returns for HVAC system. Again, best practice would be to not do that. We just if we do use framing cavities, we need to make sure they're properly air sealed so that we're not losing conditioned air or drawing in unconditioned air into that system. Again, just a few diagrams of this, making sure that we have the proper insulation on any ductwork, whether it's flexible or rigid, still needs to be R8. Duct sealing. If you notice, ducts with joints not located entirely in the conditioned space shall be sealed. Best practice is to seal all ducts in all locations to minimize duct leakage, which will allow that duct system to distribute the conditioned air as designed and intended. Again, if their ducts are located outside of the conditioned space by code, then the ducts would have to be sealed. Best practice is to seal all ducts, joints, and unions and takeoffs, whatever the case may be, with an improved sealant, whether it's a chemical weld, a gasket, a mastic embedded fabric, or tapes. We need to make sure that those tapes and mastics comply with UL 181. And if we have insulation that wraps our ductwork with a continuous air barrier, it can be used in place of that sealing of metal ducts. So if we have a metal ductwork for plenums, if we wrap it with an air barrier or an insulation with an air barrier and seal that, that will work for the air sealing. Tapes with rubber-based adhesives are not permitted. For example, duct tape. So we need to make sure that it is not a rubber-based adhesive tape. When we look at substance, as long as the tape's marked UL 181 or we have a mastic of some sort, you can see all the seams on the right-hand side of this graphic, the longitudinal seams, all the seams at adjustable elbows, every joint should be covered or sealed with a mastic or a tape material. The application of mastic, typically over time, I've always referred to it as being approximately the thickness of a nickel to achieve the best sealing possible. And it doesn't have to be more than just the half a brush width across that seam. We're not going for complete coverage of the duct, just making sure that this seam is sealed. So again, especially when we have elbows, there are a lot of seams within an elbow, a metal duct elbow, that needs to be properly sealed off. And this is a section of 322.43 regarding duct and plenum sealing. Okay, duct testing is not required if the air handler and all ducts are in conditioned space. If something is outside of the conditioned space, then one of the two are required. So we have our post-construction test. So with that, rough end say leakage to outdoors should be no less than 8 CFM per 100 square feet, or CFA, or conditioned floor area, or total duct leakage shall be less than or equal to 12 CFM per 100 square feet. We could wait or do it as a rough end test. And if you notice at rough end, total leakage shall be less than or equal to 6 CFM per 100 square feet. And if the air handler is not installed at the time of the test, that total leakage test shall be less than equal to 4 CFM per 100 square feet. So the less that we have in place, lesser chance for proper sealing, and the remainder of the equipment installed, the greater potential for leaks. A post-construction test is best. Okay? Although if the ducts are extremely leaky, it may be difficult or sometimes impossible to seal those ducts by common means, whether it's tapes or mastic. So we can do a rough end test to find out where we're leaking, get the duct sealed. You can do a post-construction after the test, the fact then to make sure that we're still achieve that leaking percentage. This is something that will be demonstrated in the future. We'll be advertising for a blower door and duct blaster demonstration a few times through June of this year. So be on the lookout for those dates if you want to come out and watch how Robbie sets up the blower door and duct blaster and runs a test on the HVAC system in the home. Within the code for SPS 322.45 are air conditioner and heat pump efficiencies. This is a rather large table. This is just an example of part of it. So it's partial table. The table extends quite a bit within the code itself. So just be aware that there is a table that specifies the minimum efficiencies for equipment pertaining to air conditioners and heat pumps. Again, here are just a few of the things. It's important to remember when the equipment is from different manufacturers. Now, the designer of the system needs to show that the specified components meet UDC requirements. So this is just passage of the code 322.45, just outlines the process in which the efficiency rating shall be calculated and supported by with data furnished by the manufacturer. They can be found on AHRI website or from the manufacturer themselves. Occasionally, will have mixed matched manufacturers or different types of equipment that you don't get a get the testing data on. So when that happens, we need to use that. The supporting data needs to be furnished for the designer and from the designer for code based to demonstrate that that combined efficiency meets the intent of this code section. Every dwelling needs to be equipped with a heating system per SPS 323. When the cooling system is provided, you must meet the sections of the code. The heating and cooling system should be designed to maintain the indoor design temperature at outdoor design conditions, and we'll show that on the next slide, which can be found in UDC Appendix A. And then when requested, this is where that room by room heat loss and heat gain calc should be furnished. That would be the Manual J. Distribution system should be sized and located to satisfy the heat and cooling loads of each space. That's a Manual D. And then when requested, you may have to supply a layout of that distribution system to show that it meets the intent of the code. Again, knowing that we can accomplish all of these passages with Manual J, S, and D. Making sure we have proper loads, heating and cooling load requirements, we have proper sizing of equipment, and we have proper distribution system layout and design. This passage, Appendix A, pertains to the outdoor minimum temperatures found in this document. It's a little tough to make out with the outline of the state, but you can see where the zones break across from zones 1, 2, and 3 within Wisconsin. So we have these outdoor design temperatures that must be abided by. So now, since we got most of the code sections reviewed, we're going to jump into what Manual J, S, and D actually are. So when we look at these are found at ACA, creates Manual J. As you can see, it's residential load calculation. Manual S is residential equipment selection, and the Manual D is residential duct design. We get into commercial, there's a whole nother series of documents that will be used. There's also a Manual T that's available for residential construction for distribution grills and excuse me, the systems itself. So whether it's a register, cover, or grill, the different information that's used in conjunction with the J and the S to use in the D design. So we come down to the actual flow that's needed to go through the room is going to relate to the grill or the cover on the end of that ductwork that we have installed can affect the distribution. So everything should be installed in concert, following through the steps procedure. So who is ACA, Air Conditioning Contractors of America? Yeah, they provide the information and guidance on heating, ventilation, air conditioning, building performance for contractors, builders, code officials, so forth. They write the standards for the design, maintenance, installation, testing, and performance of indoor environmental systems. Your contractors could be ACA qualified. They're all ACA assured contractors. And you'll see when we look at some of the software packages that are available a little bit later here in the slideshow that the software will be saying powered by ACA or approved by ACA for version J8 or whatever the current version of the Manual J is. So that software has been looked at and approved by ACA to be used for design in accordance with their publications. So the ACA design process, we start out with trying to get our ACA Manual J in place, or the load calculation. Again, that determines heat loss, heat gain based on code requirements in the building build as designed. And we'll expand on that here in a few slides. So the next step in this, obviously, is a Manual J. We design the model within the software, knowing our building components, our doors and windows, our insulation values, orientation of the home, the size of the home, room by room calculations within the Manual J. The Manual S, equipment selection and sizing, is based on the desired HVAC equipment. So the manufacturer, the capacities of that equipment to make sure that they meet or exceed the Manual J requirements. The Manual J itself can impact the sizing, as well as putting anything like system zoning. Because if we add zones in the system, that's going to change some of our sizing requirements. And then finally, after we have our Manual J done, we have our Manual S. We know that which furnace and air conditioner or outdoor unit, an indoor unit on the air conditioner or the heat pump, whatever the case may be. That's decided. We have our heat loss, heat gain for the building, and we have a required CFM from the design. We can then go on to the duct calculation. And that's a manual D. That's a duct system design size that includes all supply and return ducts and registers based on manual J and the manual T. And that manual T is entitled Air Distribution Basics for Residential and Small Commercial Buildings, as it pertains to supply outlets, return inlets, registers, and grills, for instance. So using all of these in conjunction, we can get a properly designed system, which will lead to a system being properly balanced and increased comfort for the occupants, hopefully decreased energy costs, as well as prolonging and extending the life of that HVAC equipment that's been installed. And you can find this link in your handout. These are just some brochures that are available from ACA. You could go on and download those at your leisure. This is difficult to read, but just be aware that these are out there just to discussing what manual J's and manual S's are, just for some additional information on your end. So poll question 1. Robbie's going to take care of the polls. That'll pop up on your screen. You could answer along with that. Which of the following is not an intended result of ACA design process? Well, we have a few attendees, so if we get a couple answers, that would be great. This is not a measured learning, but we still would like you to participate with the poll questions. We'll give about 45 seconds or so to answer. We'll move on from there. I think we have 5 questions in today's session. Okay. We'll go ahead and close that out, Robbie. So we have a third of everybody said well-sealed ducts, adequate control of humidity, and avoiding premature equipment failure. All of those, except for well-sealed ducts, would be an intended result. The UDC has requirements for well-sealed ducts. The manual J process does not. We go ahead and close that. The well-sealed ductwork will come into effect whenever we get a little bit further into the presentation. We'll show you how you can assign duct leakage within the manual J process. So if you know or think that the duct leakage is going to be fairly leaky or standard, there are different selections that we can put into the calculations up front so that we can forecast where we're going to be, with our design, so that if we know it's going to be a leaky system, or if it's an existing system we're running sizing, if we have unsealed ducts, we know it leaks, so we're going to lose that conditioned air. So that's going to be part of what we can adjust into our calculations of the manual J. So thank you for along with those poll questions. So why manual J's, S, and D's? For years, we used a rule of thumb, right, pertaining to how many tons of cooling do we need per square feet, or how many CFM per ton. There was always something, whether it was 400 square feet per ton or 400 whatever CFM per 7-inch line. A lot of rules of thumb in the past. Does that work currently? Rules of thumbs are not ideal. They may have worked for older homes. They may not work for modern energy efficient equipment in the codes. So how can we determine the heating and cooling requirements based on what we've done in the past? Sometimes we'll be correct. More often, we're able to alter that HVAC equipment that could be installed when we do a manual J versus we know that this home of this size in the past, we put a 3-ton air conditioner in with a 72,000 BTU gas furnace. That's what we're going to put in and just put 7-inch distribution lines to every room. That may cover, may not. It could be detrimental to the home. So when we look at our designs, do we design a house built in 2025 the same way that we did in 1970? Codes have changed quite significantly. Does it just meet the minimum requirements of code, or do we design the system so that it could meet above code programs? Energy Star, Zero Energy Ready, Passive House Design. All of those programs above code are going to have additional requirements that need to be met. When we look at the design of the home itself, as it states, 15% window to wall ratio, meaning 15% of the area of the overall exterior walls are glazing. How does that impact the manual J if during the construction process on the right side of the house, as we see on the screen, they decide to put a triple window on the first, a triple 3050 window on the first floor. That's another 45 square feet of glazing. Is that going to drastically change our window to wall ratio, which has an impact on our heating and cooling design? Is there a difference between the house facing north or east or west or south? Based on the glazing, if the back of the house is a full glazed wall and it faces south, it's going to have significant heat gains from the sun, from solar activity. If that back of that house faces north, we may not have as much in that solar gain calculation. And that's what the manual J takes into account. We set our air leakage up for the home itself. How leaky is our building shell? Is it 2.5 ACH? Are we going to be testing to 5 to 7? We need to set those parameters within the manual J calculation so we know how much conditioned air we're losing to outside or how much unconditioned air potentially we're drawing into the structure. Making sure that our ducts are tight, as we discussed earlier. Leaky ducts in attics, if they're supply ducts, we're going to be pushing conditioned air to the outside. If we have unsealed returns in the attic, we're drawing air in. We can be overpressurizing, and we'll talk about that. I think what I mentioned also about, because we always did it this way, we're throwing a 7-inch line to every room. Well, that may or may not work based on the airflow and the distance for that line to run, the amount of turns and so forth. So all of that needs to be calculated in, which comes down to the terminology of friction loss. So the longer the pipe, the more bends and turns. These diameter all affect how the air flows through, at what speed and volume that it gets to its final destination. So that all relates to what's known as the friction rate of that ductwork. Some consequences of proper sizing. Okay, so undersizing, obviously, undersizing of equipment, whether it's a furnace or an air conditioner, could lead to problems throughout the life of that equipment. Okay, so equipment can short cycle, meaning you can run in at high capacity or max capacity for a short amount of time, then shut down and start back up and shut back down in alternating periods. So that can it can allow for hot or cold occupants. We can't reach our intended temperature, whether it's in the cooling season or the heating season, because that heating or cooling plant just can't keep up with the BTU requirement to overcome our heat loads or our heat losses. So if we oversize equipment, same thing can happen. We can have detrimental equipment run. It doesn't function as intended. You're going to have higher costs. So if the manual J and S would say we would need a 2.5 ton air conditioner in the house, and we put a 4 ton in, there's a significant cost difference just between the 2.5 and the 4 ton equipment. Okay? We can have lower equipment efficiency if it's extremely oversized, because again, it's not running as it's intended. You have the opportunity to not remove the humidity from the air when we're running short cycling on equipment or for short amount of times at high volume. We don't get that humidity out. The temperature swings are another thing that's huge that we have to be concerned with. The very temperature variation throughout the house. The room should be pretty much the same temperature from the first floor, second, third, all the conditioned areas. And of course, if we oversize or undersize the equipment, we can end up with premature equipment failure or increased service costs. So everything mentioned can impact the cost to operate this system. Proper benefits, proper installed system. Again, right sizing has major benefits to everything that we mentioned. More consistent temperature. We can control the humidity better. We have the increase in equipment efficiency because it's designed for the application. So it can lower our operating expense. We can prolong the life of the equipment because it's running at maybe a lower speed or lower intended capacity for a longer period of time or continually. And it's easier on the equipment and better for the equipment to do that. And of course, when everything is properly sized and properly operating, all we would have is maybe annual maintenance to minimizing these service calls. That brings us to pool question 2. We just talked about this. Should be relatively easy for you. Manual J and S prevent what? Undersizing of equipment, oversizing of equipment, both, or neither, or neither, depending upon how you look at that. Okay. Looks like we have about 100% of it. People agree with both. Yes, proper sizing, over and under. So if you can close that poll out, Robbie, appreciate that. Thank you. So yeah, the proper sizing, manual J and S, make sure that we have equipment that is not undersized or oversized. It's accurately sized for the anticipated heat loss and heat gain in that structure itself. Okay, so now we're going to jump into the manual J, what the manual J's are. So again, calculates our heat loss, heat gain for multiple building types. That could be residential. Typically, residential construction is where we're at with this because the title says residential. So it could be townhouses, could be duplexes, could be single family. Okay. This manual J calculation is available from ACA. They do charge for this document, and it gives that step-by-step instructions on how to do the calculation process. And we're applicable to conventional building types. So maybe up through Energy Star program, when we start getting into passive solar designs, large solariums, and so forth, then we may have to bring in some other type of design, manual J or heat loss, heat gain calculation, especially when we get into passive solar homes. You get into FIAS homes and so forth. We need to bring some other design work into this. Again, this is not designed for commercial buildings. That's manual N. So residential construction is our manual J. Again, we've been talking about right sizing of equipment. So again, you're going to hit on this again, using that manual J in conjunction with a manual S. So we look at our calculation requirements, our airflows. Then we can design and select our equipment based on those requirements of the building as projected and be able to deliver a comfortable environment and a efficient environment for the occupants going forward. Again, manual S based on the loads calculated in accordance with manual J or one of the other heating and cooling calculation methodologies. So if there's something else we came up, another method that was approved by Wisconsin, by the UDC, as well as ACA, then we could use those and then use manual S for the sizing. So some other things that are found in that manual J document, just some basic principles, definitions that go throughout, some various calculation tables that were needed for manual J within the calculating heat loss and heat gain, and then the different appendices that are there for multi-zone systems, which can change our equipment sizing quite drastically at times, depending upon the size of those zones, number of those zones. So if not familiar with zoning, if we had one furnace in the home, and each the first floor and the second floor had thermostats. So if it was cold on the second floor, it would heat the second floor. Air would be sent to that area only if the first floor thermostat was still meeting the requirements. So and it could work vice versa as well. So zones, or it could be zoned down to as much as a single room within a particular structure or system. We have appendices on our energy consumption and some detailed infiltration estimates that can be used in the design process. So when we look at design temperatures or design conditions, this is a excerpt from Elite Software, one of the packages that's available for calculating manual J. And throughout this presentation, you'll see some screenshots from various packages. We're just showing you some of the ways that some of the representations or visual representations that the different packages and software packages will give you. So they will look different from different types of software, but this is one example from Elite Software. We select our reference city. In this case, for this demonstration, it was just Harrisburg, and it would fill in our winter and summer temperatures automatically. And then we'd have our latitude and elevation for that area. So these design temps should be in the software. So we pick the nearest reference city to the location for our home. And that gives us our indoor design temperature, which is the target indoor air temperature for comfort and efficiency. When you see that what the outdoor design temps are, the heating temperature, that's the the temperature above which the outside air is 99% of the time. And the cooling temperature is when the temperature is below, which is the outside air temperature 99% of the time. The goal is to calculate those BTUs in that blower CFM for our fan blower, air handler blower, to maintain an indoor temperature 99% of the time when the in between those outdoor temperature ranges between 0 and 95. We'd want to make sure that we're able to maintain that indoor design temperature set forth in the code 99% of the time with the equipment. So types of loads that we have, from in a heating season, for example, how heat leaves a home. Heat will always go to cold unless acted upon by another force. If we have additional energy placed in, so heat's always going to go to cold. So we have heat loss from the structure in various fashions. Through our doors and windows, or fenestration. Making sure that our U factors, our SHGC, which is going to come into effect on our cooling side, but the U factor of that window and door is low enough so that it meets the requirements of the code and performs at a high level. There are above grade walls, making sure that we have adequate insulation in place, as well as our below grade walls. There is a difference between heat loss from a insulated basement through the foundation wall to ambient grade than there is from an exterior wall above grade to ambient conditions or outside air. The heat that we lose through our ceilings and our roofs, whether it is a flat ceiling with blown insulation or batt, or slope ceiling, or an encapsulated attic where maybe spray foam was sprayed on, insulation was applied to the roof deck. How are we losing the heat through that ceiling and roof? We also lose heat through our slab and any of our floors over garages, floors over ambient space or outside space, floor over an unconditioned basement. Making sure that those floors are properly insulated and sealed as well. It's because we don't want that infiltration or exfiltration of air in or out of the structure, which would allow for conditioned air to leave the home or unconditioned air to come in. So we're kind of defeating the purpose. The old adage of we're not paying to heat the outside, but if our homes are not properly insulated and sealed, we could be doing exactly that. We need to take into consideration ventilation practices, whether it's spot ventilation for bathrooms, how much does that contribute? It's not really addressed in a manual J for bathroom ventilation that run only when there are occupants in the bathroom. But if we have continuous mechanical ventilation or whole house mechanical ventilation, then that needs to be taken into consideration. Because in theory, we're exhausting conditioned air to the outside intentionally. Then we need to be bringing in unconditioned air into the systems as a makeup. And how much do we actually lose through our duct system? Just whether it is from duct leakage or from conduction through the system itself. So taking into consideration all of these ways that a home can lose heat through the structure. So we would want to mitigate those and account for all of this when we do the manual J. Make sure that we have the proper insulation values in place. Now we also have the proper leakage values assigned. So we have heat loss during the heating season. So we get heat gain during our cooling season. Same thing, doors and windows, big part. SHGC, we get into northern climates, it's not as prevalent as in the south, but we want the SHGC, meaning the solar heat gain coefficient. How much energy do we gain just from the sun shining on this particular home as we see it? Same way with our above grade walls. Are they reflective? Are they light colors? Or are they dark colors? We can take that into account in the manual J software as well. So in this situation, the walls are light. The roof could be a medium or a dark, depending upon how we interpret that color. They're all going to affect, both of those are going to affect the heat loss and heat gain through the structure itself. So we lose, again, cooling through our ventilation systems, conditioned air to the outside. That's going to be a heat gain because we're extracting that air to the outside. We're bringing air in through any leaks in the home. So unconditioned air during the summer coming in is going to increase our cooling load. Some of the big things that are not often taken into consideration are number of people. How many occupants are in the home? That's a pretty big one. We want to make sure that if it's a 4-bedroom home, we have at least 5 persons assigned through the home, whether it's to certain rooms or typically those 5 individuals or 5 persons within that assigned to that home would be split up, say, into the living space and the kitchen, where the going to be the high occupancy spaces. We can also assign appliance loads for kitchens, laundries, entertainment centers. We have a movie theater or a room where we know a home office. We can add additional load into sensible load requirements into our manual J calculation, so that's taken into account. Because if think about the amount of computers and monitors and LED TVs, all these are giant radiators putting heat into the structure. So we take that into account so that we have that additional heat load accounted for. Lighting is another big one. Making sure that we have the lighting loads taken into account. How much heat are we gaining from the lights? So the loads, the cooling loads, can be offset with that heat gain through all of these avenues, and things that can be addressed through best building practices, and to account again for the persons of the home as well as the appliances within that manual J calculation. And it's important when we start to uh, list all of these items, whether it's a heat loss or a heat gain, that it can be accounted for within the manual J and overcome. And sometimes it's not a huge gain on the BTU offset, but occasionally it might be a rather large gain. So we may find out that a track builder, this size home, based on heating and cooling gains, and historically they put the 3-ton HVAC system in, say heat pump, and then when they run the manual J, they find out they maybe need 3.5 tons for this house. Or 3 tons would work in this orientation, but if this house turns 180 degrees, it may need to go up a half ton or it could drop half ton. So the orientation is important when we take into consideration the gain, the heat loss and heat gain calculations. So here are some of the softwares that are available. On a complete list, again, you can go to aca.org/standard/approved software to find this. Just some of the examples that are out there. Some of these software packages that I have experience with have a steeper learning curve than others. Some of them are rather intuitive. So it does take some time to understand the software package that you could be using. And we don't advocate any one package over the other. They all have their end use in mind in providing that manual J calculation and manual S. ACA has a checklist available for manual J input verification. This is just a portion of that checklist. You find that on their website. It just gives you some additional questions if you're going through for the design or review of a manual J. Some of the input verification we look at. The example shown on the left is from RightSoft. This is a load form for the entire house, and it just gives us our design information, the project information at the top, design information in the middle, and then we'll be looking for the outside design characteristics, the outside design temperatures, dry bulb temps, and the heating and cooling temperatures, excuse me. We need to verify that they match our location. Again, this example is not necessarily the Madison-Dane County Regional Airport, but that could be one of the sites that we would have get the information for heating to them. We're going to heat to use a -3 Fahrenheit and 87 degrees for our cooling design temperatures. And then we verify our indoor design temperatures, typically set to 70 in the heating, cooling on the 75. That's what we want to look at on this project information or design information of a manual J to make sure that we have those calculations, especially if it's outlined or required by code, and if we have an above code program as well that we have to pertain to. Windows, glass doors, skylights are all entered in. This is an example of construction where we have walls, windows, doors, ceilings, floors, so forth, areas, the components themselves. So we'll have a square footage area of a room. So this is the basement layout of this space. So it gives us the orientation of walls, north, south, east, and west. Square footage of those, it calculates the insulation factor. It also will then take into consideration the amount of glazing that we have in each of those windows based on the entries of the software. The doors the same way. We can have our ceiling insulation specified. You see with this, it's ceiling under vented attic, no radiant barrier, which is a reflective barrier attached to the roof sheathing itself. Dark shingles. Again, where I mentioned about the color of the siding or the roofing material, and specifying the R30 roof insulation gives us our area at that point. And then anything else as floors. So in this case, we have floors over radiant panel over basement, and we have tile covered basement or floor. So additional entries. We want to make sure that we have the manual J includes the walls and the windows, doors, the insulation values throughout, because that's how it will calculate the heat loss and heat gain that we have to overcome. Again, this is just an example of some data inputs that you may see on a manual J. They're by no means current code requirements. So don't use this as an example from a code perspective, but just purely an example of the components. And custom components can be entered within the various software packages. And want to making sure that our R values match. Do we have our walls and ceilings to the proper insulation over the floors? We get down through. So we looked at our walls and windows before, so now we get it deeper into insulation. Does this match the plan, or does match what we have seen on site? Because again, if we miss and we put an R, say in this situation with the R ceiling, we're going to have a different heat loss, heat gain calculation if we put an R60 ceiling in instead of an R30. Or if this 30 was placed by accident when it was supposed to be 60, there's going to be a difference. The same way with our walls, or our windows. If our values for our windows are not entered, we pick a baseline window and the home as built is built with a triple pane, ultra high efficiency window, there's going to be a significant difference in our heat loss, heat gain calculation. So we want to make sure that our specifications that are on the building envelope assemblies match declared values on the plans or what we find on scene here at the site itself. I mentioned earlier about infiltration and leakage within software. This is, again, from Elite Software. We can put in our construction type from loose to tight. Okay, then this gives us our infiltration. We tell it what type of home it is, how many exposures, meaning how many sides of the house are exposed to air. If it's in a real tight environment where we have a zero lot line, you may change the number of exposures. If it's a townhouse or a duplex, it's going to change the number of exposures as well. So based on the square footage conditioned floor area of the entire home, not just the system served, we can select our construction infiltration. How we think it's going to test, basically, is what it comes down to. Making sure that we get that information in so that we know, and we allow the software then to provide that ventilation number in its calculations. So we define that air leakage based on the construction type and our constructed floor area, and then we can include our whole house ventilation fans if they're in place, but not spot ventilation. We will add additional CFM in place for our whole house ventilation if it is in place at that time. If it's just bath fans, we don't include that. But if we're running a whole house fan, say an HRV or ERV, then yeah, we're going to include that flow within the manual J calculation so we know what we could be exhausting to the outside or bringing in that's unconditioned. We can also apply our duct location. So in this slide, we see that on the right-hand side, the software is asking us for a duct location. So it can be in an attic, it can be an unconditioned basement, it can be within a floor system, an exterior wall, within conditioned space, buried below the attic insulation. We assign the building component. In this case, a designation 16B just means that with the software that it's an R30 ceiling insulation. We assign our duct leakage, where we think we're going to be with our duct leakage, or where we would like to be. And so we can aim for that. Our duct insulation value, our surface area calculation, duct work will be calculated based on the run. So all of this works in conjunction to give us some sensible loss and gain calculations of system one based on our duct work. We do this for each of the systems that are in place. So if we have two systems, we would do two of these layouts, two of these particular data entry points that would be unique to each of those. So we could have one system that's in the attic, and system two could be completely within conditioned space. So they'll have different calculations attached to this. So all of this is used, in conjunction with the distribution system or the layout to be able to determine what the end run will be, what our distribution is going to be, what's our required CFM at the end of our ductwork. We get into additional internal gains, as I mentioned, about people and equipment. So within a room, this is a individual room assignment in Elite software. There is a bedroom. So this is being designated as a bedroom 1. It gives us our width and length of the room, the height of our ceiling. So we're calculating conditioned floor area and volume of that space. The software will attach it to a system, the system 1 or 2, or the user would assign it to the appropriate system and or zone within that. And we add in our requirements, our building components. So this looks like it has floor over an area. Excuse me. We have floor insulation. We also have ceiling insulation. So this is just a partial screenshot. But we would have walls and then our fenestration or our glazing and our doors, exterior glazing and doors on down below within the software. And you would assign that to a particular wall and assign orientation by wall based on the plan set. Then we would add in people and equipment. So in this case, say it's a master bedroom or an owner's suite, we would have 2 persons in that space this designer chose, and they add an additional 300 BTUs of sensible equipment load, maybe for TVs or computers or something in that space. If it's a kitchen, we might add 1,200 BTUs for kitchen appliances at a minimum. Might put 4 of the occupants in the kitchen if it's an eat-in kitchen, or in the family room, and just make sure we have those distributed around. So rooms can have people attached, as well as additional sensible and latent heat loads. So typically occupants are a number of bedrooms plus 1. So a 4-bedroom house would be 5 persons. 3-bedroom would be 4 persons. Okay. Normally we wouldn't go through and design the home to be having 18 people in the house when there's only going to be 4 living there. That becomes very detrimental once we get into above code programs such as Energy Star. You can't do that. We can't assign more occupants to the house than there are a number of bedrooms, plus 1. So there are standards to follow with that. So even if a homeowner decided they were going to entertain regularly and they wanted to put 6 people in the living room and 6 in the kitchen at all times, but there were only 2 occupants of the house, technically that shouldn't be allowed because we're adding unnecessary load. We're not going to get an accurate representation of the house. The results from the software analysis can be in a myriad of things. Can be bar graphs, can be pie charts, can be just numbers. So those reports can be generated in all of those formats and more, and may differ slightly based on the software package. But we can see with this representation of the heating load where the portions are going to above grade walls, how much percentage of heat lost through our ceilings, through our doors and windows, our ductwork, and so forth. And again, this can be done in a different format. This particular pie chart doesn't have the percentages, but we can show that as well, different representations. So we get a nice breakdown with this based on where we see where our heating losses are and our heating gains and cooling losses are across the board. So then we can maybe address some things. We'll look at that and say, oh, wow, that we have very poor performance on our windows on both heating and cooling. Maybe if we increased to a better window, we could change that number and decrease our load or heating and cooling requirement offsets. So when we look at our room by room detail, we can have total building summary. This is again from Elite. We get a total building summary at this point based on all of our components. And then we can come down through and look and see that this total building supply summary air would be 380 CFM. Square feet of the room area is 3,009, whatever the numbers would be. And then we also have our building loads or heat loss, heat gain, all in here, and some appropriate notes from the ACA, from the software based on the ACA Manual J. Again, these Manual J calculations are only going to be as accurate as the data that's entered into the software. So if we put in building components that aren't quite what are in the home, we're going to get an inaccurate result. We definitely don't want to falsify or put in a better ceiling insulation or wall insulation when it's not actually what's in the house. Or we don't want to say that we're going to be at 2 ACH air leakage when we run an infiltration test in the home test at 7. That's going to be a significant difference. So, next poll question. Exaggerating the number of bedrooms in Manual J is likely to result in oversized equipment. True or false? Okay, Robbie, you want to close that out for the answer? Okay, 75% of you said true, 25% said false. And that would be true. Again, we don't want to say that 8 people are living in the house when there are only 4 or 3. We could offset that load and result in equipment sizing changing. Okay, so we go ahead and hide that. We'll move on to the next slide. So now we get into the Manual S. We've gone through the process of gathering all the information of the plans. We've done a plan takeoff to know each of the different room sizes within the house, including walk-in closets and bathrooms, areas that we know that maybe have a heated or cooled assembly or register to those. Again, this is best practice to do this, to get that shape of that room, that model built. We're going to take that number. We have X amount of BTUs heating we need, an X amount of CFM BTUs or cooling CFMs that we need, and then the total CFM required for the home itself. So one room in the heating mode may require more CFM to it than it would during a cooling season. So when we look at the documentation, the calculation of total CFM of the home, it's going to take the higher of those two numbers and then add that in, because our ductwork will need to be sized for say if they need 100 CFM of heating into a bedroom, but cooling is only requiring for 60 CFM, that could be different duct sizes. So we want to make sure that we have the appropriate size in place. So we take all that information, we go to the Manual S. So the Manual S, this uses the Manual J calculations, as I talked about, to determine proper sizing. It also gives us the instructions on how to interpret performance data from the manufacturers. So the manufacturers will have all types of charts listed for heating and cooling capacities. It's CFM, and these capacities change based on blower speed and so forth. So they give guidance on how to use that data to select the proper equipment. Sets the limits on equipment sizing, right? And we'll talk about that. And it's not applicable, as we mentioned earlier, for commercial, industrial, or institutional buildings. So the Manual S, we're going to get to our design specifications, design conditions from the Manual J. Get that total heat loss, heat gain calcs, right? Then we look at our manufacturer's performance data of the equipment. So if we have a specific piece of specific manufacturer in mind, then we say, hey, we want to use this furnace. We want to use a 95% efficient gas furnace from this manufacturer. Then we looked at the equipment data. We find that the performance of that particular equipment. We can take that information. We get our information from Manual J for a sensible heat calculated, and that's used to size that blower motor. So does our furnace, we look at the data for the furnace, does it cover our CFM flow? Does it cover our heating requirements? The same on our cooling side. We pick our heating and cooling plant, the outdoor equipment, the indoor equipment. Does it match with our furnace? Do we get a gain in compliance or testing when we have equipment that's been tested together? So the furnace, the indoor coil, the air handler, and the outdoor unit, they're all tested together. Do we have an AHRI document for all of that equipment together, or is it just on the cooling equipment on the outdoor? The outdoors, the HVAC air conditioning equipment, excuse me. Or do we have just a document for the furnace? When we look at that testing data as well as the manufacturer's design data to determine the heat loss and heat gain, or how many BTUs we can get out of that unit with that combination, and at what CFM. So does the furnace have a high enough output to overcome our heat loss? And can we get a blower speed, a fan speed? Can we deliver enough air at that BTU range that's required by the manual J? So using all of that information, as well as the manufacturer data, again, which can get quite complex at times, we can determine what's needed from a furnace size and air conditioning size to meet the HVAC desired airflow as intended by the manual J. So here's some of the equipment sizing review calculations. Heating equipment, should the calculated heat loss could be up to 40% oversized or 140% the capacity of that furnace. If the furnace is 160% of the required airflow or the required heat loss, then it's oversized. We should maybe look at the next nominal size down. So it's 140% or the next nominal size. Cooling equipment, whether it's central AC equipment, split system, or a heat pump, the central AC should be 115% of calculated heat gain or next nominal size. Heat pump, we could go to 125%. Then when we look at our design airflow, we'll make sure that the rated airflow equipment or rated airflow for the equipment on medium speed is within 15% of that design airflow. Excuse me, because we don't want to have a fan speed or a fan blower that's distributing or producing 100 or 1200 CFM of air when we only need 800 CFM based on the manual J. That extra airflow, we're going to be sending additional air, which could compromise the heating or cooling effect at the desired location because we're getting too much air distributed. We're going to lose temperature. We can introduce noise into the system. We have to be concerned with getting that air back, not overpressurizing the system. So we want to make sure that we're within that plus or minus 15% of the designed airflow. And here's an example. The manual J calculated heat loss is 50,918 BTUs per hour. The desired furnace, must meet or exceed these required BTU loss. So when we look at the oversizing, we could oversize up to 40%, right? So a 50,918 BTU heat loss times 1.4 could be in that up to 71,285 BTUs. So it would be the range of the furnace that we would have to fall within. So our proposed furnace is a 52,000 BTU per hour output. So it would just barely cover the requirement. We'd have an additional 1,000 BTUs. So, we could bump up to the next size, provided it wasn't over 71,000 BTUs. But this furnace, by the manual J calculation, would cover the required heat loss based on the maximum output of that unit. Keep in mind, you can oversize by that 40% up to that next nominal size. Cooling example. And so if we have 27,543 BTUs of cooling that we need to overcome from a heat gain, 15% of that. So we could go to 31,674 BTUs on the high end. Our proposed AC output, or the output of that air conditioning unit, is 30,000 BTUs at max. So does that fall in? We're covering the 27,543 BTUs with the 30,000, and we're below the max, the oversizing output. Now cooling typically, in case you didn't know, could be relayed to ton. 1 ton of cooling is equivalent to about 12,000 BTU hours. Excuse me. So residential equipment, typically 1.5, 2, 2.5, 3, 3.5, 4, and then 5 tons are the common sizes. When we look at that, when we look into some of the information for cooling equipment, you may see sensible and latent heat. We mentioned that earlier, sensible capacity versus latent capacity. Sensible is felt or measured by a thermometer. That changes the temperature of an item without changing its phase, meaning we increase the temperature of an item without, say, changing water to steam or ice to water. Latent heat is that energy required to change the state of a substance without altering its temperature. So once we reach 32 degrees Fahrenheit with ice, we then have to apply additional latent heat to change the 32-degree water. So late sensible is the sensible number is what we're looking at to overcome with our heating or cooling loads within a home. Our blower speed, how much airflow do we need? Again, we want to make sure that we're within that plus or minus 15% of our design airflow. In an example, we have 1,116 CFM, acceptable to be plus or minus 15%. So 1,115 would be additional 167 CFM at 15%. We add that to the 116. We could go as high as 12,083, or we could go as low as 949. So this particular fan motor set on medium speed would allow for 1,000 CFM airflow, which falls in between that range. So that blower falls within that desired range, the CFM for this piece of equipment in our design. If we go to ACA.org, you can see this ACA plan review form that's available for your download. Just to give you some additional information if you're going through to create a manual J or interested in looking at the process, you can add some information to this form as you go through design temperatures or building construction, area, windows, doors, things like that. So we have a cross-reference if we're going to compare manual J to the plan set. Pool question number 4. Manual S sets oversizing limitation for central AC systems at 115% the design output capacity or next nominal size. We'll launch that pool, Robbie. True or false? We are allowed to have 115% oversizing for central AC systems. Okay, so we have 50% of you said truth, 50% said false, and the answer would be true. Remember, there is a difference between air conditioning and heat pumps. When we look back, heat pumps can be 125%, central air conditioning equipment to be 115%. Okay, so we'll have a few more slides here, and we'll see if anybody has any questions. We get on to the manual D. So we have our manual J completed. We have our manual S. We did the calculations, looked at the tables, said, yeah, this furnace and this air conditioner meet or exceed what we have to overcome heat loss, heat gain within the parameters set forth. So proper duct design is very, very critical. We need to be able to get the air to the desired location at an intended speed so that we're not introducing noise into the system in a comfortable situation with movement of rapid air, that too high of a flow, that the air has cooled down too much by the time it got there. So we want to make sure that it's designed properly and that we're getting the correct CFM to that space. Again, we don't want to have a room over a garage where the register is only giving out 30 CFM this time of year because it's probably going to be a very cold environment. Yeah, that manual D document gives us an outline for proper design. And through the proper design, the distribution system takes into account, obviously, the loads for the manual J, the airflow from the furnace as designed by the manual S, duct lengths, and how the system is arranged. So we have to know the blower motor, how much capacity can it give out, our air conditioning coil, how much air can we get across that coil in a given amount of time into our ductwork. Is our ductwork properly sized for supply and return? Supply going out, return coming back in. What restriction do we have in place by our filter? These are all going to take into consideration or be taken into consideration during the manual D process so that we can ensure proper airflow. So here's an example of a duct distribution system. So this is what we want to propose, getting registers to these intended locations. So the next step is to use manual D to design this system. So we take the duct preview Again, this is from Elite Software. This is an example of that manual D report. And you can see the cooling flows in this situation. There are 2 columns for heating and cooling. And then when we look over to the next column, it says actual flow. And what that's going to represent is the highest of the 2, heating or cooling. As you can see, each of these spaces require a different cooling or heating flow, depending upon the season. And then the software will give us a duct size and a register size. So we want to make sure that the register, the register and the ductwork is sized to be able to get the higher of the 2 airflows throughout the home. So this is in a prominently cooling required environment. So this would be in the southern environment. So we may have a different design of the same home in Madison than we would in Florida. So again, we need to make sure that we have the higher of these 2 flows. So these are all tabulated and added up, and that gives us our total airflow within the home itself. So we need to make sure that the duct system is designed to move that amount of air. Here's an example that, again, when I said we have heating flow column, this bedroom would require 33 CFM of heating. Okay, but it needs 92 CFM of cooling air. Okay, so that actual flow in the next column is the largest of the heating or cooling, like I mentioned. And then it tells us that we would need to have, by the software calculations, a 5x7 ductwork, and our register would be 6x10 at the end. Now, some of these software packages, when we go back to this design, it can take into consideration and size these based on actually using a CAD layout within the software, so we could size the duct, whether it's flexible or rigid ductwork. They could size that ductwork based on the flow that we assign to those individual areas. Okay, so when it finally comes down to reading the report, it encompasses a cover sheet as well as individual documents throughout. So your cover sheet in this example is from Elite. Again, we don't particularly endorse any particular software package, just be aware there are numerous packages out there. If we're using an HVAC software to provide a manual J and S, we want to make sure that the document says verified by ACA, or it's ACA approved. Okay, we should see that the preparer's information will be on the cover, typically with most of these software packages, as well as the address, that information, so we know that it's address specific. Things that we're going to look for on the report. We talked about location correct. We want to make sure it's in the right city, because that's location is going to be important. In this example, it says Lowell, Massachusetts. If this home was being built in Wisconsin, that obviously is not the correct design reference city. So the temperature, if you remember back to the temperature tab, the design data, the temperature is going to be different. Making sure that our infiltration rate that we have set within the software does not exceed code. So if code requirements said 5 ACH, we couldn't set it to be 7. We need to make sure that the ACH, or the infiltration within the manual J calculation, matches the code requirement. Does the building area match? Making sure that this square footage room air is 3,009 square feet. Does that match the plans? Because we don't want to have a manual J for something that's manual J designed to 3,000 square feet when the plans are only set at 2,000 square feet. That can be detrimental, obviously. Same way with the volume. Does that add up? Volume is going to make a difference. If we have an 8-foot ceilings versus a 10-foot ceiling home, that volume, if the ceiling height was not adjusted within this model, could change our design requirements. And again, does the orientation match? And that's the big one. Which way does the front door face? How's it designated in the software? Could be garage, could be front door, whatever the case may be. The building orientation needs to be set properly, because it could deviate. Obviously, a sizing of cooling equipment from east to west or east to north. And I've had that happen to me too many times over the years, where identical homes, one across the street from the other, were a half-ton different size, purely just based on their orientation. Had the same windows, they just were rotated 180 degrees. So that happens. Making sure that orientation is absolutely correct and matches the as-built. So things that we need to look for on our duct preview. Making sure that the highest flow is the highest flow actually used when we look at this. The friction rate in the design, is it less than 1, meaning how restrictive is the ductwork? Or total effective lengths of our supply and return ducts, are they shown? Do they add up? Do we have duct sizes for each space? And do we have registers for each space? Now, again, not every manual J software is going to do this, and not every submittal is going to have register sizes on here also, but a proper design is going to have all this information in place. So just remember, total effective length of ductwork is important because that falls back to our duct surface area under our design conditions. So last poll question, and we're going to wrap up here. So to achieve optimal occupant comfort and energy efficiency, which of the following should be considered regarding residential heating and cooling? Okay, we go ahead and show the results, sir, Robbie. We got 100%. Everybody said all the above, and that would be correct. Again, the whole presentation harping on proper manual J design to get proper sizing of equipment and incorporating our proper ductwork. So, in summary, we want to make sure that we step away from the rules of thumb. We don't want to say 1 ton of air is for 400 CFM or a 7-inch duct can distribute 100 CFM. Maybe, maybe not. Make sure we step away from the rule of thumb because it could change based on the house design and the orientation. If at all possible, we're going to use that software that's powered by ACA and approved by them. Makes a huge difference. Gets you accurate sizing. Make sure we have accurate inputs into our home and we have the design temperatures correctly, entered correctly. Our component areas, surface area of walls, ceilings, floors, our R values and U factors of our insulation of doors and windows. Set our infiltration rate right. Don't hurt herself by saying it's a 7 and it's going to be we put in the software as a 3 ACH and we know it's going to be 7. Make sure we get taken into consideration so we don't have those callbacks or improper design. If we have whole house ventilation in place, we need to include that because that can change our heat loss, heat gain pretty drastically. Properly sized ducts, properly insulated ducts, accounting for our internal loads, making sure that we have those people and appliances applied to the correct rooms. And when we look at that manual S oversizing, making sure we don't go past that 140% on heating, the 115 for cooling, or 125% for heat pumps. Stay within those limitations, and it will help to provide for a properly designed system, which leads to comfort for the end user and less operating expenses, plus less expense initially for the installation of the equipment. So if you have questions, again, you can reach out to us at these phone numbers or email addresses. And again, we'll try to get back to you within 24 hours. If you have suggestions for training sessions, please add those into the question pane or send them to one of the emails. If there's something you think you could be a benefit subject, we'll gladly come up with a proposal for a subject matter and develop a program to present if it's something that you think we could be used across the board. Do we have any questions? Yes, and as Connor says, it is very important that we make sure those manual JS and Ds are provided to those organizations that are verifying that, i.e. the code inspector. You get it to the HERS rater that's doing the Energy Star inspection or just the home testing, and any other party that requires that documentation. Thank you for that, Connor. Very important to make sure everybody has that information. Because I know when I was a code inspector, I would want that, so I'm walking around looking, making sure that it matches. And then when I became a HERS rater, the same thing. Say, hey, well, this furnace is too big or the AC is undersized, doesn't meet program requirements. Okay, and I see your recommendation. Thank you for that. So if anybody has any other questions, you can throw them in the question pane in the next minute or so. If not, I'll give you a couple minutes back of your day. And you can always reach out to those email addresses with any questions, concerns, or comments. So I want to thank Robbie for sitting in. Again, he's available in state as well. And some of you may be seeing him in the very near future or being contacted by him. I want to thank Adam Smith, who is also our director. There is in the background as our program head of our program is there. So if there's no other questions, I want to thank everybody and enjoy the rest of your day. Remember, we have upcoming training throughout the next few months. So we hope to see you there. Thank you.